Okay, so day 2 of factoring. Go ahead and pause this video and try these problems to make sure you can do them. Okay, last chance. Make sure you've practiced these. So here are the answers. Take a look at number 1 and notice I didn't do a box because it was just an x squared. There's the coefficient in front of the x squared is a 1. And in that case, when you do the diamond problem, this will actually tell you what goes into your factors. So we had a -5 and a 3, so x minus 5, x plus 3. But on number 2, when you have to do the modified diamond, because there's a number other than a 1 as the coefficient of the x squared, then you have to do a box. So I had to multiply these together to get the product. So I came up with the 8 and the -1. Remember, that tells you how to fill in the x's in the box. The 2x squared goes in this top left and the -4 in the bottom right. Then you go through and pull out a GCF. On number 3, I did a diamond problem. Notice I didn't do a box. That was because the coefficient of the x squared was a 1. And it turns out that you end up with two -3s here. So when you factor it, you get x minus 3 times x minus 3. Or, because you're squaring that, you can write that as x minus 3 quantity squared. Number 4, there's a GCF of a 3x that you can pull out, and that's the only kind of factoring that you can do on that, is the GCF factoring. Okay, so we're going to do some special cases today. So these are some unique ways that we have for factoring a couple different situations. One of them is this, x squared minus 25. If you take a look, there is no GCF, so I can't pull out a common factor. And it's not set up for a diamond problem, because notice I don't have an x term. I only have the x squared term and the constant. But let's think of it. Suppose it was x squared plus 0x minus 25. And if it were, and you went ahead and did a diamond, so we would have the product is -25 and the sum is 0. So my two numbers would be 5 and -5, because if you multiply them together, you get -25. If you add them, you get 0. Now, you could do the box. This would be a situation where I wouldn't have to, but let me just show you how that would work. My x squared here, my -25 here. Remember, this tells me how to break up the x's, so I would have a 5x and a -5x. So if I pull out my GCF here, I have an x. This would have to be an x to make that work. This would have to be a +5 to make that work. This would have to be a -5. So my answer I get when I factor this is x plus 5 times x minus 5. Now, notice if I had skipped the box, I'd have been okay. Because the coefficient of the quadratic term is a 1, I could skip that and just use the 5 and the -5 when I factor that. So if we do this the same way, so now this time there is no GCF, but notice here I have a 9. It's not a 1, so I'm going to have to do the box. So if I go through and multiply this, because I'm going to have to multiply a 9 times a -16. So we get 144, and it's negative, and my sum would be 0. So I need my two numbers that multiply to -144 and add to 0. Well, 12 times 12 is 144, so one of them would have to be negative, so that works. But because it's not a 1, it's a 9, I have to do the box. So we'd have a 9x squared here. The -16 goes here. So I'm going to have a 12x and a -12x. Pull out my GCF. I can pull out a 3 and an x, which makes this a 3x to get the 9x squared, which means this has to be a +4 to get my 12x, and this has to be a -4. So I end up with 3x plus 4 times 3x minus 4, and that would be my answer. So there is an easier way, and this is a formula. A squared minus b squared equals a plus b times a minus b. This is called the difference of two squares, And trust me, knowing the formula makes your life much easier. Let me go back and show you on here. Notice that the square root of 9 is 3. The square root of x squared is x. So the square root of 9x squared is 3x. So I had a 3x right here in both those spots. The square root of 16 is 4. So I had a 4 in both those spots. One was a plus, one was a minus. So that's how the difference of two squares work. So looking up here, I had the square root of x squared is an x. So notice I have an x. The square root of 25 is 5. So I have a 5. One's plus, one's minus. So that's how that formula works. And it's not a big deal really. This one you could do with a diamond problem, but you get to some of these other ones and the numbers would get rather large. But so notice 25x squared is a perfect square. The square root of 25 is 5. The square root of x squared is x. The 81 is a perfect square. The square root of 81 is 9. And it's a minus. It has to be a minus in the middle. It's called the difference of two squares. So I end up with 5x plus 9 times 5x minus 9. And that's done. You can always double check if you FOIL it or put it in a box. You will find that you get 25x squared minus 81. So always want to check for that. That's the difference of two squares. Now we're going to take a look at this one, and we're going to factor each trinomial. Notice that the leading coefficient is always a 1 here on all of these, so I don't really need to use the box, and I'm going to do that as a shortcut and just do a diamond problem. So here, my product is 4, my sum is 4, so my numbers have to both be 2. So I get x plus 2 times x plus 2, or I could call that x plus 2 quantity squared. Next one. The product is 16, the sum is 8. So that means it's going to be a 4 and a 4. So I can write it out and list them twice, or my shortcut, x plus 4 quantity squared. Next, the product is a 1, the sum is a negative 2. So that would be a negative 1 and a negative 1, because if you multiply them, you get a positive 1. You add them, you get a negative 2. Again, I don't need the box on this because it was just a 1x squared. So I get x minus 1 quantity squared. And then the last one, my product is a 9. My sum is a negative 6. So that's going to be a negative 3 and a negative 3. So I get x minus 3 times x minus 3, or I can say x minus 3 quantity squared. These are also special cases, and they are called perfect square trinomials. And we have two formulas that go along with that. You have a squared plus 2ab plus b squared equals a plus b quantity squared, and then you have another one if it's a minus instead. So notice the difference. If it's a minus, then this is going to be a negative right here. So here's when you would want to try that. Now, for most problems like this, if you don't recognize that this is a perfect square trinomial, it's no big deal because you just do a diamond problem and look how easy it was. But on a problem like this is going to be a lot more complicated if you did, because it's a 4x squared, it's going to be a lot more complicated because you'd have to do a modified diamond in a box. And sometimes the numbers can get kind of large. So this is when you're going to check to see if you can use this formula. If you look at the first term, and it's a perfect square. So the 4 is, and so is the x squared. So we get a perfect square here. And if you look at the last term and it's a perfect square, then that's your clue. Okay, this might be a perfect square trinomial. So what you do is you take the square root of this, and if you do, you'd get a 2x. You take the square root of this, and you get a 5. And this 2ab part, if you multiply 2x times 5, you get 10x. Double it, and you get 20x. So that would be the check, how you would check to make sure. Now, the other thing you can do is if you notice this is a perfect square and you notice this is a perfect square, then just make a guess and say, okay, I think it's going to be 2x. Since they're both plus, it would be a plus. The square root of 25 is 5. So I think my answer is going to be this. And then just FOIL it. If you do the first 2x times 2x is 4x squared. The outside is a 10x, the inside is a 10x. So that gives you the 20x in the middle, and then 5 times 5 is 25, and everything was positive. So that would be how you can use this formula for a perfect square trinomial. So this had, again, two special cases. One of them was the difference of two squares. So this is a formula. You probably won't have to try to memorize it because you're going to use it so much. Then this formula, you may or may not memorize the formula. If you just remember that it involves taking the square root of the first and the last term, and then you can kind of do like I did here and think about what it's going to be, and then just double check your answer to make sure the middle term works. So that was the perfect square trinomial.